Linear inequalities and interval notation. Let's look at our first problem. We've got 2 times the quantity 1 minus x plus 5 is less than or equal to 3 times the quantity 2x minus 1. To start solving this linear inequality, we will start distributing. So 2 times 1 is 2, 2 times negative x minus 2x plus 5 is less than or equal to 3 times 2x is 6x, 3 times negative 1 is minus 3. So now we'll combine our like terms. We've got negative 2x on the left. We'll combine 2 and 5. So plus 7 is less than or equal to 6x minus 3. We want to get all of our x's on one side, the constants on the other. So I will add 2x to both sides, and I'll get 7 is less than or equal to 8x minus 3. And then I'll add 3 to both sides, and I'll get 10 is less than or equal to 8x. I'll divide both sides by 8, and we'll get 5/4 is less than or equal to x, because I canceled out 2's. And even though 5/4 is less than or equal to x is a valid way of writing the solution, we will often see the x written on the left. So if I reverse everything around, the inequality symbol flips, and it is x is greater than or equal to 5/4. Now, if we're trying to write this in interval notation, what's the smallest number that x can be? 5/4. And because it's greater than or equal to, we're including the 5/4, which means that we have a squared off bracket. And then we'll put a comma, and the largest number that x can be is infinity, because it keeps going, all the numbers greater than or equal to 5/4. And because infinity is not a number that can be included, it's an idea or a concept, we will have a curved parenthesis. So here is, in blue, is our interval notation representation of the solution. If we want to look at the graph on a number line, I like to put a few numbers like 0. Here would be the marking for 1, so 5/4 or 1 1/4 would be about here. So our graph would be having a solid filled in circle at 5/4 and shading all the numbers greater than or equal to 5/4. So shading to the right. So just kind of a reminder, inequality symbols that include the equal bar, so greater than or equal to or less than or equal to. When we write the interval notation and representation, we will have squared off brackets. If we didn't have the equal bar, we would just have curved parentheses. And when we're graphing on a number line, we would have closed in solid circles. If we didn't have the equal bar, we would have open circles. Okay, let's look at some compound inequalities. This basically means that we have an and or an or in our inequality statement. So here we have 2x minus 1 is less than 8, or x minus 5 is greater than or equal to 0. So we will solve each of these inequalities separately. So I'll add 1 to both sides and get 3x is less than 9. Divide both sides by 3. X is less than 3. On the second one, we'll add 5 to both sides and get x is greater than or equal to 5. The solution, we actually have to include both of them with the word or. So x is less than 3 or x is greater than or equal to 5. If we write this in interval notation, so if I look at the left part, x is less than 3, the smallest number that x can be is negative infinity. Infinities always have the curved parenthesis. The largest number that x can be is 3, but 3 is not included, so we have a curved parenthesis. For the or, we write the union symbol. And then for x is greater than or equal to 5, the smallest number that x can be is 5, and we are including the 5, so we have a squared off bracket. And then all the numbers greater than or equal to 5, so the largest number would be, or representation would be infinity. And because infinity is not an actual number, we have the curved parenthesis. So this is our interval notation form of the solution. Looking at this on a number line, so I've got 0, I've got 3, I've got 5. So if I graph the first part, x is less than 3, open circle at 3, graphing to the left, shading all the numbers less than 3. The second part, we've got a closed circle at 5 and shading all the numbers greater than 5. So we have two parts, two arrows going in opposite directions. Example 3. So here we have an and inequality. We have 1 minus 4x is less than or equal to 21, and 5x plus 2 is greater than or equal to 22. Again, we will solve each inequality separately. So I'll subtract 1 from both sides. Negative 4x is less than or equal to 20. I'll divide both sides by negative 4. I get x, negative 5. And remember, with inequalities, if we are dividing or multiplying by a negative number, we need to flip the inequality symbol. In this case, it was originally a less than or equal to, but we are dividing by negative 4. So it flips and becomes greater than or equal to. So we have x is greater than or equal to negative 5. In the second one, we'll subtract 2 from both sides. We get 5x is greater than or equal to 20. Divide both sides by 5. X is greater than or equal to 4. And we need the and in between. So before we state that that's our final simplified solution, let's look at what it is referring to on the number line. So I've got 0, I've got negative 5, I've got negative 4. If I graph the left-hand side, x is greater than or equal to negative 5. I'm going to put a solid closed circle at negative 5, shade everything to the right where all the numbers are greater than negative 5. If I represent the second one in purple, I've got x is greater than or equal to 4, so I'll put a closed circle at 4 and shade everything to the right of 4. And what we're interested in is where is the overlap. So the overlap is right in this area. And basically I can summarize the overlap with the inequality statement, x is greater than or equal to 4, which in interval notation has the squared off bracket 4 comma infinity curved parenthesis. So then our final graph is just the overlap. So solid closed in circle at 4, shading to the right. Let's look at another example of an and. So 5x minus 2 is less than or equal to 3, and 4x plus 7 is greater than 3. So I'll solve the left one first. I'll add 2 to both sides. 5x is less than or equal to 5. I'll divide both sides by 5 and get x is less than or equal to 1. On the second one, we'll subtract 7 from both sides. 4x is greater than or equal to negative 4. Divide both sides by 4. X is greater than negative 1. So I've got x is less than or equal to 1 and x is greater than negative 1. So again, before we write our simplified form of this, let's look at what it looks like on a number line. So if I look at the left inequality in blue, so x is less than or equal to 1. It's including the 1, so I'll put a closed circle and shade to the left. If I look at the second one in purple, x is greater than negative 1, open circle at negative 1, shading to the right. And we see our overlap. And we can represent this as negative 1 is less than x is less than or equal to 1. So this is one compound inequality without the literal word and. It's kind of sometimes called a tripartite inequality, or I'll unofficially call it a sandwich inequality because the variable is sandwiched between two numbers. In interval notation, our smallest number is negative 1, and it's not included. So I have a curved parenthesis, negative 1, and then comma, our largest number that x can be is positive 1, and that can be included because I see the equal bar. So squared off squared off bracket. And then our official graph is just the overlap. So open circle at negative 1, closed solid circle at positive 1, shading in between. Number 5. So we've got negative 5 is less than or equal to 4 minus 3x is less than 2. So again, this is an implied and compound inequality. This implies negative 5 is less than or equal to 4 minus 3x and 4 minus 3x is less than 2. But we can write that all together in one tripartite inequality. Or again, unofficially, I call these sandwich inequalities. So here we have our x in the middle. If we think of our inequality as having three different parts separated by the inequality symbols, and we want to get x by itself in the middle. So I'll start by subtracting 4, and here I have to subtract 4 in three different places, separated by the inequality symbols. And we'll end up here now with negative 9 is less than or equal to negative 3x is less than negative 2. Then we'll divide everything by negative 3, so all three places. We'll get x in the middle. We'll get positive 2/3 on the right. We'll get positive 3 on the left. And because we divided by a negative, we need to flip our inequality symbols. So the less than or equal to becomes a greater than or equal to, and the less than will become a greater than. So we have 3 is greater than or equal to x is greater than 2/3. And this is a perfectly valid way of writing this, but often we'll see our inequalities written from smallest number to largest number. So often you'll see this written as 2/3 is less than x is less than or equal to 3. So I reversed the numbers. I had to flip the symbols. And so by the 2/3 was originally a greater than, and it became a less than when I turned it all around. And by the 3 was originally a greater than or equal to, and it flipped when I turned it around and became a less than or equal to. In interval notation, the smallest number I can have is 2/3, not included, so curved parenthesis. Largest number I can have is 3, which can be included, so squared off bracket. On a number line, so here I've got my 3, 2/3 is about here. So open circle at 2/3, solid closed in circle at 3, shading in between. Okay, so try this problem. 9x minus 2 times the quantity, 5x minus 1, is greater than 6 minus 2x. So pause this, try to solve this inequality, and then also try to write the solution in interval notation. When you're done, come back and check your answer. Okay, so we have 9x minus 2 times the quantity 5x minus 1 is greater than 6 minus 2x. So 9x will distribute. Negative 2 times 5x is minus 10x. Negative 2 times negative 1 is plus 2. It's greater than 6 minus 2x. I'll combine like terms. 9x minus 10x is negative x. plus 2 is greater than 6 minus 2x. I will add 2x to both sides, and I'll get x plus 2 is greater than 6. I'll subtract 2 from both sides, and I'll get x is greater than 4. That's my solution. And if I'm writing this in interval notation, the smallest number that x can be is 4, and that is not included, so curve parenthesis. And the largest number that x can be would be infinity, although infinity is not really a number, and infinities get curved parentheses.